The chemical element sodium. Sodium has the symbol Na and it is in the first main group and the third period. Sodium almost have the same chemical properties as lithium and potassium because it is in the same main group. The main group tells us about how many electrons there need to be in the outer shell, and the period symbolizes how many shells there are circling around the nucleus. Sodium is in the first main group and the third period, so it must have 1 electron in the outer shell and 3 shells circling around the nucleus. Sodium has the symbol Na, and the atomic number is 11 because it has 11 protons in the nucleus. The atomic mass of sodium is 22.990 because 11 protons plus 12 neutrons in the nucleus, it gives about 23 unit. The state of sodium is at normal pressure and temperature is a shiny, soft, and really reactive metal. This is sodium lumps. But when sodium gets contact with atmospheric air, like it have done right here, it becomes rusty. So the state of sodium is solid, because this is sodium. But you can't find sodium lumps of sodium in the nature because they are extremely reactive. There are 13 isotopes of sodium that we know, but it's only the isotope sodium-23 that are stable. This one here. An isotope is a different model of the same atom, and now we're talking about sodium. This is the atom. It has the same atomic number, the number of protons, like right here, but it has a different atomic mass right here, because the isotope sodium-24, it still has 11 protons, but it has 13 neutrons instead of 12, and that give us an atomic mass on 24 instead of 23. Right here you see a shell model of the atom sodium, and this is the nucleus. The blue one is the protons, and the protons are positive charge. And sodium has 11 protons in the nucleus and 12 neutrons in the nucleus, that are the red one right here. And the neutrons are not charged, they are neutral. So this is the nucleus. And around the nucleus we see the green rings. This is the shells, and the sodium has 11 electrons spread out in 3 shells, and the electrons are negative charge. So if sodium needs to be stable, it needs to have the same number of protons that are positive charge as electrons that are negative charge. And in the inner shell, we can see this shell. We can see there are 2 electrons, and in the second shell, we can see there are 8 electrons, and in the outer shell, there are just 1 electron. Sodium can go on iron form, and when it does that, it loses 1 electron, this electron, and then it get positive charge because it loses this electron, and just 1 electron. And when it does that, it has 8 electrons in the outer shell, and all the elements in the periodic table want to have 8 electrons in the outer shell because the outer shell is full. And it look like the noble gases in the 8th main group. So when sodium goes on iron form, it's gonna be the ion Na+. And because sodium wants to lose an electron, and chlorine wants to gain an electron, it's a very good match, because sodium gives 1 electron to chlorine, so they both achieve the octet rule. And down here you can see sodium achieve the octet rule. It just have 8 electrons in the outer shell, and chlorine achieve the octet rule because it also have 8 electrons in the outer shell. So they help each other, and they are very good reactants. And this is a reactance in this chemical equation. This is the reactants on the left side of the arrow. So we have 2 Na plus Cl2, and it gives the product on the right side of the arrow 2NaCl, which is sodium chloride, also called salt. And now I want to show you an experiment with sodium. And as you can see, we got a lump of sodium, about 1 gram, and a bowl full of normal water, H2O, right there. And now we see how sodium reacts with water. The lump becomes smaller and it's fizzing around the ball, and it's generating lots of hydrogen gas and the reaction is burning away all of that hydrogen, which you can see the orange sodium flame. You saw it right there. And when the sodium lump has made so much heat with the hydrogen, it ends up exploding. As you can see right now, it explodes. So the chemical equation of this one is that we have the Na, that was the sodium lump, plus the H2O, that was the aqueous solution, the just normal water. This is the reactants in this experiment. It gives us the product right here on the right side, that is H2, which the hydrogen gas, plus NaOH, that's the aqueous solution, but with some sodium in. And we need to balance this chemical reaction because there's not the same number of atoms on the both side of the arrow. So we need 2Na plus 2H2O, which means we have 2Na plus 4H, and we have 2 O's, and that gives us the H2 plus 2 NaOH instead of just 1 AOH. So we use sodium in our daily life to have the yellow light in our lamp posts on the street, like this one, because some sodium gas makes the light become yellow instead of the white and sharp light, and that's more cozy to have this one than the white shite light. And in some soaps, there are sodium as an ingredient because it has a higher melting point than potassium, and it makes the soap more solid. So that's a better idea. Thank you for watching. I hope you have enjoyed. This was my presentation about sodium.